In this video, we're going to quickly go over using velocity or speed. So speed is equal to the distance over time. It'll be the change in distance over the change in time, and the change in distance is equal to the distance final minus the distance initial. The change in time is equal to the time final minus the time initial. Time is scalar, so it's always going to be, it doesn't have a direction. Distance is also scalar, but if it was a vector, this is called velocity. So this is speed, and this is velocity. Velocity is a vector because it uses the change in displacement over the change in time. So we've done some displacement and distance calculations before, but when we're using the speed or velocity, and they're essentially the same kind of a calculation, I always leave this kind of calculation till later if it asks like what's the final distance or what's the final position. I would do that part separately from the velocity calculation or the speed calculation. Now, to rearrange the speed formula, if I wanted to solve for distance, so first of all, the way this is set up to find speed. Speed has the units of meters per second or kilometers per hour. If I wanted to find the distance, though, I've got the distances in the numerator, and so I'll just take my t across the equal sign, and then my d equals v times t. If I wanted to solve for time using this, I need to get to the time out of the denominator, so I get it across the equal sign, and I'll be left with t times v equals d. But that doesn't then solve for the time. I then need to isolate time. So I'm going to take my v and go across the equal sign. And so my t equals d over v. And I kind of wrote that as a mess, right? So going from this, if I'm trying to solve for t, my d is here, and the v, as it crosses the equal sign, goes below. So these are my three variations of this equation. And when we're doing a calculation, I will always want to have the original formula and then show the rearrangement to solve for the thing. So I've got some examples that are here that are fairly straightforward. The first one asks for a change in speed. I am going to organize the information that was given in the question, maybe have a simple diagram, write down the formula, substitute in, and then get my final answer. So you'll see that again, another diagram, my variables, and then I substitute into the equation to get my final answer to the right sig digs. The next question, though, gave you a speed and gave you a time. It's important to be organized to know what you've been given. So because they want distance, I needed to solve for the distance. I need to get it by itself. So the t crosses to the other side, and the change in distance equals v times delta t. I also have my meters per second times seconds, so the seconds cancel out and leave me with meters. I have 2 sig digs in this number and 2 sig digs in this number, so my final answer must have 2 sig digs as well. So if I was going to go to this question I have been given meters per second. That's a speed, so 4.50 meters per second, and then they give me a time is 150 seconds. So I've got v equals d over t, and I want to solve for d. So I'm going to take t to the other side. D equals v times t. So d equals 4.50 meters per second times 150 seconds. And the distance is going to be 675 meters. My seconds canceled out, and so it left me with meters. I have 3 sig digs here and 3 sig digs here, so I need to have the same number of significant digits here. Let's take a look at number 7, and in this case, it's got a speed is 700 meters per second, and it has a distance of 180 meters. So we've got a bullet that's traveling at that speed and that distance. So V equals D over T. I know V, I know D, they want time. So to solve for time, I need to get it out of the denominator, and so I'm going to have T times V equals D, but I still want to solve for time. So then my V needs to go to the other side. T equals D over V. And if I put that into this, I have 180 meters divided by 700 meters per second. So it's going to take less than a second, right? So I've got 180 divided by 700, and my calculator tells me it's 0.2571428, blah, blah, blah. And in this case, it's meters, and there's 1 over 1 over seconds. So that's seconds. Now, I had 3 sig digs in this number and 3 sig digs in this number. I'm dividing, so I should have 3 sig digs here. So it'll be 0.257 seconds. Okay. It's also important to make sure that you've got the same units. So in this question, they give you a speed and a time, but you can see your time isn't the same units. This has got kilometers per hour, and this is days. So one of the things you need to pay attention to is the units. We'll maybe do some more of these questions in another video, but hopefully that helps you kind of rearrange and remind yourself about how velocity and speed calculations work.